Okay, in this video, or I guess it's not really a video, it's a presentation, we're going to talk about the states of matter and physical change from one state to another. You're probably familiar with all these physical states. For instance, the top one is a solid, and solids have definite shape and volume, and there are very strong forces holding the particles of these solids together, so they don't move fluidly like a liquid or a gas would. A liquid still has attractive forces holding the particles together. They don't escape easily from one another. They have a definite volume, but they don't necessarily have a definite shape. They take on the shape of the container that they're placed in, or at least the bottom portion of that container. Gases do not have definite shape or volume. They basically expand to fill whatever container they're placed in, and there's very little attraction between the particles. In chemistry, we'll observe different types of processes, and we'll want to be able to distinguish between physical change and chemical change. In physical change, we're basically changing from one state to another. Although the substance may appear quite different between phases, it's still going to retain the same chemical formula. So liquid water is still two hydrogens attached to an oxygen, solid water is still two hydrogens attached to an oxygen, and water vapor is also two hydrogens attached to an oxygen. Chemical change, on the other hand, is going to change the arrangement of the atoms. So if I burn natural gas, methane, then I start with the molecule methane that has a carbon atom bonded to four hydrogen atoms, and I I react that with oxygen molecules that are in the air, and I'm going to change the arrangement of these atoms in the products. So I'll end up with carbon bonded to oxygen and hydrogen bonded to oxygen. I can see that this isn't balanced, but we'll talk about balanced chemical equations in the next unit. When we're looking at physical change, we're changing from one physical state to another. So I'm changing from a solid to a liquid, or a liquid to a gas, or even going completely from a solid to a gas in one step. We've got names for these processes. Technically, in science, we refer to changing a solid to a liquid as fusion. You might call it melting, and I'll probably even call it melting. Fusion just seems like kind of a weird word that doesn't necessarily fit, but remember that your book will certainly refer to it as fusion. Vaporization makes more sense. We're changing something from a liquid into a vapor, so vaporization is what we call the change from a liquid to a gas. And then the fancy word of the day here, sublimation, is changing a solid into a gas. Now, one thing we want to consider in all of these is how energy is being exchanged in changing a solid to a liquid or a liquid to a gas. So the way I think about this is I try to think of myself as the solid. So if I'm the solid and I want to change into a liquid, I've got to get my particles moving faster, so I've got to absorb energy from the surroundings. So if I'm absorbing energy from the surroundings, then we say that this is an endothermic process. Likewise, when I change a liquid into a gas, I've got to absorb energy from the surroundings if I'm a liquid and I want to change into a gas, and the same for changing a solid into a gas. All of these processes are endothermic, and if I turn them around and change a liquid into a solid, or a gas into a liquid, or a gas into a solid, so let's first talk about the names of all of these. We're sticking with a good name for changing a liquid into a solid. We still call it freezing. If we change a gas into a liquid, it's condensation, and then if we change a gas into a solid, we call it deposition. And if these processes, or the previous processes, changing a solid into a liquid, absorbed energy, if I'm going the opposite direction, I have to lose energy. So a liquid has a higher kinetic energy than a solid, and in order to freeze, it's got to lose that energy. It's got to give off that energy. So all of these processes would be exothermic. Since we're not face to face, you don't get to see me, wave my arms around, but I drew up a little cartoon here for an endothermic process. I'm absorbing energy from the surroundings, so that means that I kind of point towards myself the direction that the energy is flowing. On the other hand, if I'm dealing with an exothermic process, I'm losing energy and the energy is pointing away from me, so that's what I think of as an exothermic process. Exothermic process, that would not be as energetically spontaneous because you're going to have to supply energy from another source in order to get that up there. Where the one where we have a ball already at the top of the hill, that's going to be a lot more spontaneous. I have to just give that a little poke and that ball's going to spontaneously lose all that energy. Just like the stick man who met a untimely demise in a previous slideshow. And I think that